All right, the next part of the worksheet that we're going to look at is dealing with summarizing the data from the first 4 questions. So what I did is filled in the summary chart for you. So what you're looking at is the trend. So as your frequency goes up, so you'll see all of these are 10 to the 14th, so you just have to look at the m value, or the number in front of the times 10. So you'll see those are increasing, and then if you look at what's happening to the wavelength, you're going to see that the wavelength is decreasing. Okay, and again, this is looking at direct versus inverse. So since they're opposite, this is an inverse relationship. So we saw that with Boyle's law in the gas law chapter. And we're going to look at these proportionalities. So the lambda part of this is the frequency is proportional to either 1 over the wavelength or is directly proportional. So since it's inverse, and again, this little alpha sign here is the proportional to symbol. So for this one, because it's inverse, they are proportional to the 1 over the wavelength. Okay, the next part of this is looking at the equation that Planck discovered between frequency of electromagnetic radiation and its energy. So this equation is E equals h nu, and in words that means energy equals Planck's constant, and I'll give you that value in a minute. So just like the speed of light is always constant, this is as well, and times frequency. So Planck's constant is 6.626 times 10 to the negative 4th joules times seconds, or joules per hertz. So you'll see again either of those units for that. So energy is going to be in a unit of joules. So joules are similar to calories. So in English system, we count calories for heat. And then, like I said, Planck's constant, joules times second, or joules per hertz for that. And again, frequency, seconds to the -1, 1 over seconds, or hertz. And again, you can see how multiplying joules times seconds to the -1, or 1 over seconds, cancels the seconds and gives you joules, or you're going to be looking at joules per hertz times hertz will cancel and give you just joules. So since these are on opposite sides of the constant, so the other way I could do this is I could do E over frequency equals h, which is like a constant. So remember when we divided, so D for direct. So that means as the energy goes up, the frequency has to go up, or vice versa. If the frequency goes down, the energy goes down. So that means this is proportional to the frequency. And then it's, again, just plugging in for equations. So I have frequency, I want to know energy. So I'm just going to plug in 6.26 times 10 to the negative 34th. This is in waves per second, so I'm going to do joules times seconds. And then 4.57 times 10 to the 14th waves per second. Seconds cancel. And when I multiply that in my calculator, I get 3.03 times 10 to the negative 19th joules. All right, I'm going to stop the video here. I'm going to let you do question number 2. There will be a place in Blend for you to submit that answer.